Hello and welcome to this exercise on sequences, an A-level type question. Should be okay for anybody doing a high school math as well, and for CXC math. The question says a sequence x sub 1, x sub 2, x sub 3 is defined by x sub 1 being 1. And then it says that x sub n plus 1 is equal to x sub n all squared minus k times x sub n, where n is greater than 1. Okay, and then it says where k is a constant and k is not equal to 0. Okay, and it says find an expression for x sub 2 in terms of k. Right, now x sub 2 will be x sub 1 all squared minus k times x sub 1. And when you simplify, you end up that 1 squared, because x sub 1 is 1. So 1 squared minus k times 1, because x sub 1 is 1. So that then means that x sub 2 will be equal to 1 minus k, and that's x sub 2. And for b, show that x sub 3 is equal to 1 minus 3k plus 2k squared. Okay, now x sub 3 will be x sub 2 all squared minus k times x sub 2. Now, x sub 2 we know is 1 minus k, so that's 1 minus k squared minus k times x sub 2. Now, x sub 2 we know is 1 minus k. And when you simplify this, as you got there, you got 1 minus 2k plus k squared minus k plus k squared, and that simplifies to 1 minus 3k plus 2k squared as required. Okay, and so given also that x sub 3 is equal to 1, calculate the value of k. All right, now this is x sub 3 here, so we're going to equate this to 1. So 1 minus 3k plus 2k squared is equal to 1. If you subtract 1 from both the left-hand side and the right-hand side, the 1's will cancel out, so we then end up with 2k squared minus 3k is equal to 0. And when we factorize, we end up with k into 2k minus 3. Now, k cannot be 0 as we are told earlier. So k cannot be 0. So we end up with just 2k minus 3 is equal to 0. In which case, if you add 3 to both sides, we end up with 2k is equal to 3. And when you divide both sides by 2, you end up with k is equal to 3 over 2. And that's the value of k there. Okay, now for part D, it says, hence, find the value of summation of from the first term to the 100th term. Okay, where it says hence there, it did say hence there. Therefore, we have to use the value of k is equal to 3 over 2. Okay, right. Now, this is a series. Our series is 1 as the first term, plus 1 minus k, second term, plus 1 minus 3k plus 2k squared, plus and so on. Now, when you simplify, we end up with 1 plus 1 minus 3 over 2, because k is 3 over 2 from part C, k is 3 over 2. So 1 plus 1 minus 3 over 2 plus 1 minus 3 times 3 over 2 plus 2 times 3 over 2 squared. Okay. And when we simplify, we end up with 1 minus a half plus 1 plus and so on. So it is an oscillating sequence. Okay. So in this sequence, all the even terms are minus 1 and the odd terms are 1. Okay. So in effect, we then have to sum this up. If we add the first and second terms, you get a half. If you add the third and fourth terms, you get a half. If you add the fifth and sixth terms, you also get a half, and so on. So there'll be 50 pairs there. So sum to 100 will be 100 divided by 2, because we're going to have 50 pairs, multiplied by 1 minus a half. So that gives us 50 times a half, and the answer is 25. Now you've got to be very careful here that this is not an arithmetic series, so you must be careful how you do your summation. It's not an arithmetic series. Anyway, I hope all that made some sense. Thank you for watching, and please subscribe. Bye bye now.